Okay, so we're going to calculate grams of a compound. Oftentimes you would have to have a balanced chemical equation. So first, for number 2, we are going to balance the chemical equation. So we list them. We're going to do Na, we're going to do O, we're going to do H. And because we have PO4 on both sides, we're going to pretend that that's an element for balancing. So then you are going to make your little grid. You have on the reactant side and the product side. On the reactant side, we have one piece of Na, one piece of O, 4 pieces of H, because we have the H3 plus we have the one here. And then we also have one PO4. On the product side, we have 3 pieces of Na, 3 pieces of Na, from Na3, 1 piece of PO4, 2 pieces of hydrogen, and 1 piece of oxygen. So right now, the only thing that's balanced are the oxygen and the phosphates. So what we need to do is we need to balance the most complex. So the most complex is the Na3PO4, so we have to balance the NAs. We want to leave the H2O for last. So what we have to do is we have to put a coefficient in front of the NaOH. Now we have 3 NAs. We have 3 oxygens. We have 3 times 1 is 3 plus 3 more so we have 6 hydrogens, and we have the same number of phosphates. So my hydrogens and oxygens are not balanced, but my sodiums and my phosphates are. So let's balance out the water. So then we're going to put a 3, because we have the same number of oxygens. So 3 times 2 is 6 for hydrogens. And then 3 times 1 is 3. And everything is balanced. So now we have our conversion factors, because our problem is our equation is balanced out. So now what we need to do is we need to take what we're given, which is 0.814 moles of NaOH, with a sufficient amount, with basically enough H3PO4 to make Na3PO4. So what we would do on that was we would set up what we're given, 0.184 moles of NaOH over 1. We put that in parentheses. We want to convert NaOH to Na3PO4. So we know that we have, in order to get rid of the NaOH, we have to have the same on the top and bottom. So we put the N3 3 moles of NaOH, moles of NaOH over, and then we have 1 mole of Na3PO4, put that in parentheses. The moles of NaOH cancel, so that leaves us with 0.0613. 0.0613. All right. And that leaves the units that we have left are N moles of Na3PO4 over, and that's it. So 0.0613. We want to find, we have moles of Na3PO4. Now we need to do grams. In order to do grams, we have to convert Na3PO4 into its molar mass. So in order to find its molecular mass, we take Na3 and we list the elements, Na, and then we have P and we have O. We put that in our handy dandy table, and we put the atomic mass times the number of pieces in a formula. So times. All right, and then we have our atomic mass for Na is 23. Our atomic mass for phosphorus is 31, and we have the number of atomic mass for oxygen is 16. So the number of pieces in Na3, we have 3 pieces. That's from the subscript. We have 1 piece of phosphorus, and we have 4 pieces of oxygen. So 23 times 3 is 69. We have 31 times 1, and we have 16. 32 equals 64. So then we add these all together. 9 plus 10, so 14. We move the carry of the 1. 12, 13, 14, 15, 16. 16. 164 grams per mole of Na3PO4. So now we have our conversion factor. So now we have 0.0613 moles of Na3PO4. We put that over 1, put that in parentheses, and our conversion factor on that would be 164 grams. We put that on the top because we want the moles of Na3PO4. So we're going to 164 grams over 1 mole. So the moles cancel, and now we're left with 0.0613 times 164, and that should be our answer, which is 10.059 grams of Na3PO4. So your answer for this problem is 10.059 grams of Na3PO4 will be produced when you combine it with H3PO4, when you combine NaOH and 3 moles of NaOH and 1 mole of H3PO4. So that's it, and thank you for watching. My email address will be in the description, so if you have any issues. Thank you.